Something that has been on my mind for a while is the lack of redundancy for SLS. NASA cares a lot about having dissimilar redundant capability to perform the same task, as they should. For commercial cargo, they have Dragon and Cygnus. For commercial crew, we have Crew Dragon and Starliner. And to replace the ISS, NASA has selected 4 commercial space stations. Recently, we have seen how seriously NASA takes this with the selection of HLS. Due to funding constraints, NASA was forced to select only the highest rated lander, so Starship got a sole selection. The aftermath of this decision has led to NASA promising to select additional landers in future phases, and to Congress mandating that NASA do so. So clearly, dissimilar redundancy is a huge concern for both NASA and Congress. So where's the dissimilar redundancy for SLS? In today's episode, I'll explore some options we may have. If you like space, opinion, and analysis, please consider subscribing to Apogee and helping the channel grow by liking this video. I have a store with custom designed space merch, a Discord that's open to everyone, and a Patreon if you really want to support the channel directly. Thanks for watching, and let's get right into it. SLS and Orion's job is to bring humans to lunar orbit and then back to Earth. This is one of, if not the most important part of bringing humans back to the moon for Artemis. So why hasn't Congress mandated that NASA have a system redundant to SLS the same way that they mandated this for HLS? NASA and Congress have had many years to take such action and never have. In fact, when asked directly about other methods for getting people to the moon, NASA has always responded dismissively. The most common response being, SLS and Orion are the only vehicles capable of bringing humans to the moon. Kind of admitting the problem there, aren't we? But is this true? Is SLS Orion the only way? Pretty much yes. When SLS flies this year, it will be the only vehicle capable of doing this task, and probably for a few years after that as well. And my response to this is, of course it is. This is self-fulfilling prophecy nonsense. Rockets do not spring forth from the ether. How did SLS come about? NASA funded it. How did Crew Dragon and Falcon 9 come about? NASA funded them. So when NASA says, SLS Orion is the only vehicle that can do this, of course, it's the only one you have funded. Do you expect to just find a crew-rated lunar vehicle in a junk drawer somewhere? This is like going to the grocery store and only buying bread, and then being shocked when you don't have milk the next day. Anyways, I'll leave it up to you to decide the reasoning for this dissonance, but thus far, NASA has made it clear that everything they do except SLS needs redundancy. I'm hopeful this attitude will change after Artemis 1 launches and takes a bit of the pressure off of SLS and Orion, but we'll see. Now, let's start to look at some options NASA has if they were interested. For each of the options we will discuss, we need to make sure that they are cost competitive with the SLS Orion system, and in order to do that, we need to know how much that system costs. For a long time, including when I made my original Artemis videos, we really could only estimate the cost for SLS and Orion, but now we have official numbers from NASA for both current and future SLS launch costs, so our analysis can be much more concrete. The marginal cost, according to NASA, to launch an SLS rocket stands at $2.2 billion. The marginal cost for Orion is $1.3 billion. This brings the marginal cost of one SLS Orion launch to an eye-watering $3.5 billion. I should note that this does ignore an extra $600 million in ground systems cost per launch, but we're leaving that aside for this video. The NASA Inspector General said that this price tag is, quote, unsustainable, which is not something you want to hear about the system which is meant to build a sustainable presence on the moon. This $3.5 billion cost is only for the first 4 missions, so let's look ahead. The long-term goal for SLS is to decrease cost from $2.2 billion per launch down to $1.5 billion per launch. As for Orion, once capsules begin to be reused after Artemis 5, NASA expects to save $278 million per flight, bringing its per-flight cost down to just over $1 billion. So in summary, the current marginal cost of an SLS Orion flight is $3.5 billion, and the long-term goal is $2.5 billion. We'll use that number as we analyze several concepts over the course of the next few videos in this series. So let's start it off with a concept I really like and have actually mentioned before a few times, which is using the HLS Starship as a ferry from low Earth orbit to the moon and back. There are some new variations to look at and up-to-date specifications to work with after all. In order to provide redundancy to SLS Orion, the system must take a crew of 4 from the Earth's surface to a near rectilinear halo orbit around the moon, NRHO for short, and back to Earth's surface. Notice we don't have to land on the moon, which is pretty important to point out. It can be a bit confusing since we are talking about using HLS Starship, which is technically a lunar lander. Now, let's break down the first architecture, which is called HLS Ferry. First up, the Starship depot is launched to low Earth orbit. This is part of the current Artemis plan already, so nothing new here. Since the depot launch does not return, it arrives at low Earth orbit with 200 tons of propellant on board. Next, we launch a standard Starship tanker, which transfers 150 tons of propellant to the depot, and we repeat this step once more with another tanker. The depot now contains all the fuel required for our mission. Next, the HLS Starship is launched. Since this launch also does not return, it too arrives with 200 tons of propellant on board. The HLS Starship then docks with the depot and receives all the propellant. Assuming a 100-ton dry mass, which includes 10 tons of payload, the HLS Ferry now has over 7,700 meters per second of delta V. With the ferry ready in low Earth orbit, a crew of 4 then launches on a Falcon 9 Crew Dragon to meet it, just like they do currently with the ISS. Crew transfers over to the HLS Ferry, and Crew Dragon undocks and stays in LEO. The HLS Ferry performs the TLI burn, translunar injection, bringing the crew out to the moon. There, they enter NRHO, where it would meet with whatever landing system is waiting for it, which may very well be a different HLS Starship. The HLS Ferry remains in orbit around the moon as the surface mission is conducted. After the mission, astronauts return to NRHO and transfer back to the HLS Ferry. The HLS Ferry then heads back to Earth and enters low Earth orbit propulsively. Here, it docks back with the Crew Dragon, which was awaiting its return. The crew moves over to Dragon and rides it back to Earth's surface. Mission complete. Taking a look at the full mission profile, we can see that in total, this mission requires 5 launches. No refueling takes place with people on board, and both the depot and HLS Ferry stay in space ready to be reused. Subsequent missions require 4 tanker refills and a Crew Dragon flight. Let's look at the cost of this mission. We know the price of a Crew Dragon flight is $220 million. That tells us the maximum allowable cost for the 4 remaining Starship flights. Since we want this to cost the same or less than the $2.7 billion SLS Orion flight, each Starship flight must cost no more than $620 million. So as long as the Starship launch is less than that, this system is cheaper than SLS. I can't really see that being a problem, as a good estimate for early Starship flights would be close to $30 million each. Now, what's really cool is if you doubt SpaceX will be able to make Starship upper stages reusable, this mission is still possible even without that, since an expendable tanker would actually bring up more propellant. And this expended tanker would also be very cheap, just a tube with a few engines and a nose cone. Less complex than Starship vehicles that have already flown in Texas. and here's what a cost breakdown would look like for a no reuse version of this mission profile. Anyways, if each Starship flight cost $30 million, the total marginal cost for this mission would be $340 million, a full $1.2 billion less than the SLS Orion system per mission. The real shining benefit of this architecture is that it requires absolutely no additional development. Yes, you heard that right, no additional development. Falcon 9 is flying crew to and from LEO right now. HLS Starship and orbital refilling are already required by Artemis, and its development is already funded and underway. As soon as HLS Starship comes online, this system is possible. The only thing that may need some work is giving Dragon the capability to loiter in LEO for a longer period. Really, an upgrade like this, if it's needed at all, is not very big, and in a worst case scenario, it could just dock to the ISS and wait there. The only concern I can identify for this architecture is a potential lack of crew abort options, should something go wrong with the HLS Ferry during its trip to the moon and back. Although honestly, this doesn't concern me much. It is true that for SLS Orion, if something goes wrong during some parts of the mission, Orion can separate from its service module and have a free return to Earth. But it can't do this at all times. For example, if the European service module completely fails in NRHO, Orion is stranded there. Similarly, a failure of all HLS engines during the current landing plan is also a loss of mission event. It's impossible to design any architecture that can withstand total failures at every single point. So compared to the current plan, it only lacks abort capability in a few scenarios. On SLS during the TLI burn, if the ICPS were to malfunction, the crew can abort away from this upper stage. At least that's the hope. The HLS Ferry method can't do this since it's one integrated ship. And a similar issue exists after translunar injection. Both Orion and the HLS Ferry have access to a free return trajectory to Earth. Since the HLS Ferry enters Earth orbit propulsively when coming back from the moon, some engines must be working to perform this task, whereas Orion can re-enter just using its heat shield. The reason this doesn't strike me as a big risk is because the HLS Starship has 30 engines on board to perform this burn, and that's not even counting RCS thrusters. 3 sea-level Raptors, 3 vacuum Raptors, and 24 landing engines that are super simple. It's hard to imagine a scenario where all 30 plus of these engines fail, besides of course a catastrophic destruction of the HLS Ferry. Of course, such a failure would mean loss of mission, the same as a catastrophic failure of Orion or the ESM would mean loss of mission for the current architecture. So there you have it, that's the HLS Ferry concept. Our next proposal is very similar, but modified specifically to deal with the abort limitation we just discussed. But first, I want to give a huge thanks to Spaceship Mania for sponsoring this video. His channel is all about creating detailed 3D printed models of rockets and spaceships, both in the real world and sci-fi. You all know how much I love to talk about HLS Starship, and he sent me this stunning, large-scale HLS model. This thing is probably the coolest thing I own. I've actually been collecting models from Spaceship Mania since before Apogee was even a channel. I got this really cool Starship model, which you can see here beside its updated version, and a Crew Dragon that is so cool I actually display it at my work desk. All of these high-detailed 3D printable models are available to download for free on Thingiverse, so check out the link in the description if you want to print some of these for yourself. The Spaceship Mania Etsy shop is also listed below. It's currently closed, but keep an eye out for it to reopen perhaps later this year if you want to buy finished, printed, and painted models. So be sure to head over to the Spaceship Mania YouTube channel and subscribe so you don't miss these awesome vehicles we all love being brought to life, like his most recent collaboration with Starship 3D to make the most detailed SN15 miniature in the world. Now back to the video. We'll call this next proposal HLS Tow Truck, and things are overall pretty similar. However, our Crew Dragon is getting an upgrade. The major modifications are updating the navigation system to work in cislunar space rather than exclusively in LEO, adding additional radiation protection, and adjusting the heat shield to handle re-entry from the moon. The last change is stored in the Lunar Dragon's trunk. An additional docking mechanism, same as the one on the front of Dragon, is positioned inside of the trunk facing the opposite direction, allowing our Lunar Dragon to dock with HLS facing either way. This docking port would attach to the load paths within the trunk with frangible or explosive bolts, allowing quick separation in the event of an abort, but we'll cover this later. In the space world, these changes are relatively easy. They're all known quantities, nothing new. It does take a little time and money, but not anything excessive. So, keeping that in mind, we start with the depot launch. The depot is then refilled with 2 tanker flights just like before. Next, we launch the HLS and have it fill up at the depot. We are now ready to send our crew up to dock with the HLS Tow Truck. The crew launches on a Falcon 9 in their Lunar Crew Dragon, and they dock to the HLS using the aft docking port. Docking this way achieves 2 things. It allows the astronauts to take the thrust of the TLI burn in the correct orientation, and it also allows for the Lunar Dragon to abort using its Super Draco abort motors should anything go wrong during this TLI burn. Once connected, the HLS performs the TLI burn to take itself and the Lunar Dragon out to the moon. Quick aside, Dragon's docking port is actually already designed to take this amount of thrust, courtesy of its Orion heritage from the Constellation program, so no problems here. After the TLI burn, the crew can dock the other way to the HLS and enjoy its spacious cabin, or simply remain in the Dragon for the 3-day journey, which eliminates a few docking maneuvers. The HLS then enters NRHO, and the crew can meet up with whatever lander is present and then complete their mission on the surface. Once they are done, the crew meets back up in NRHO and transfers into their Lunar Dragon. The HLS Tow Truck then pushes the stack back out towards Earth. Here, the Lunar Dragon separates from the tow truck and flies back to Earth, re-entering through the atmosphere with its heat shield just like Orion. The HLS Tow Truck propulsively enters low Earth orbit to be used again later. Mission accomplished. Now let's break down the cost of this architecture, starting with the Lunar Dragon. Now remember, this is actually only launching to low Earth orbit, just like a normal Dragon. Lunar Dragon's just the name I've given our upgraded capsule. A normal Crew Dragon launch costs about $200 million, so let's just double that and say the Lunar Dragon launch is $400 million. That means in order to stay cost competitive with SLS, the 4 remaining Starship flights must come under $2.1 billion, meaning each flight has to cost less than $525 million. Alright, so now we have detailed the first 2 feasible methods for bringing astronauts out to NRHO. I'll detail even more methods in upcoming videos, so I'm going to keep the summary brief because I plan to summarize and compare all of the methods at the end of this series. As you can see, both of these architectures look very attractive as a means of redundancy for SLS. I estimate their marginal cost per missions to be well below SLS, with the HLS Tow Truck costing a bit more than the HLS Ferry due to its use of the upgraded Lunar Dragon. No surprise that a lot of these savings are delivered by reuse of components. For both architectures, the only piece of hardware that is expended is Dragon's trunk and the Falcon 9 second stage, so the vast majority of marginal cost for these architectures would just be operational cost. Back to the summary, we can see that the key differences between the HLS Tow Truck and the HLS Ferry architectures is that the tow truck has all of the exact same abort capability as the current SLS and Orion system, but these additional abort modes come at the cost of some additional development. Crew Dragon requires upgrades to its navigation system, radiation shielding, and heat shield to become Lunar Dragon, and it also requires that additional docking mechanism in its trunk. While these modifications are simple, They still have some development cost, certainly higher than the no development required by the HLS Ferry method, but many would argue the additional safety is worth it. In my opinion, if we can spend 10 years and over $40 billion developing the first method to get crew to the moon, SLS and Orion, we shouldn't really complain about spending maybe 3 years and $1 billion for the second method, and that's being pessimistic. Now, the true benefit of these systems is that they would provide vital redundancy to the Artemis program, but they have another equally important benefit in my eyes, which is cadence. The only real limiting factor to how many lunar missions these systems could perform annually is how much NASA could afford to do. It really doesn't take a lot of annual flights to have even permanent presence on the surface. With missions of shorter duration than ISS visits, 3 or 4 flights would be enough. Obviously, SLS cannot achieve such a cadence alone at 1 flight per year, but all it would take is 2 or 3 additional flights of our second lunar crew transport method to hit that remarkable achievement of permanent presence on the lunar surface. I'm gonna keep the final thoughts simple for these videos. If I can come up with these architectures, imagine what actual rocket scientists and engineers at companies like SpaceX, ULA, Boeing, Rocket Lab, Lockheed Martin, Blue Origin, Sierra Nevada, Dynetics, and more would be capable of. It is long past time for a commercial lunar crew program, and my hope is that these series of videos can be shared around and spark that conversation in the important places where it needs to be happening. That's going to do it for the first episode. Thanks so much for watching, and please make sure to subscribe and hit the notification bell. I've had a few people reach out to tell me that they've been unsubscribed or aren't getting notifications anymore, so if you want to make sure you don't miss the next installment, be sure to hit that bell. Thanks, and I'll see you next time.